We know derivative of log of x is always 1 upon x. By definition of integration, integration of 1 upon x is the log of x plus c. As we know the note x is replaced by linear term, then take standard integration divided by coefficient of x. Here x is replaced by linear term, then the form will become 1 upon ax plus b. As 1 upon ax plus b is called radical function. Always remember, if numerator is a 1 and denominator is a linear term, it is called radical function. Or numerator is a 1 and denominator is the polynomial of x. Here linear polynomial of x is given, and integration of such a form is a log of ax plus b divided by a plus c. Using this formula, we can solve number of examples. As integration of 1 upon 2x plus 11 we have to evaluate. So I put I is equal to 1 upon 2x plus 11 with respect to x. Then its integration, as the denominator is a linear term of x, having coefficient of x is 2, is log of 2x plus 11 divided by 2 plus c. Okay, you can solve these examples similar way. As you can tell me, integration of 1 upon 2x 3x plus 5 is all log of 3x plus 5 divided by coefficient of x is 3 plus c. Similarly, 1 upon 7x minus 11 is having integration log of 7x minus 11 divided by 7 plus c. Integration of 1 upon 2x minus 5 with respect to x is a log of 2x minus 2 divided by coefficient of x 2 plus c. Integration of 1 upon 3 minus 4. Actually, here is a linear term is given, as coefficient of x is minus 4, so its integration will become log of 3 minus 4x divided by coefficient of x minus 4 plus c. Similarly, 1 upon minus 2 minus 5x has the integration log of minus 2 minus 5x divided by minus 5. Integration of 1 upon x plus 4 will be log of x plus 4 divided by 1. Actually, we did not write 1 in a denominator. And finally, 1 upon x minus 2 log of x minus 2 plus c. And last example, integration of 1 upon 11 minus x. Remember, x has a coefficient minus 1, so as we have to write integration as log of 11 minus x divided by minus 1 plus c. Form of radical function is a denominator contain linear term of x in root. As 1 upon x has the integration log of x, 1 upon root x has the integration 2 root of x plus c. This is a standard integration. Using this integration, if x is replaced by linear term of x, we can write integration of 1 upon root of x plus b with respect to x as a 2 root of linear term of x divided by coefficient of x plus c. As this is the first example, integration of 1 upon root of 7x minus 3 will be I put it as I, and I will be 2 times denominator root of 7x minus 3 divided by coefficient of x 7 plus c. Similarly, you can solve these examples. As integration of 1 upon 12 by plus root of 12 plus 7x will be 2 times root of 12 plus 7x divided by coefficient of x 7 plus c. If this root is not given, then its integration will be log of 12 plus 7x divided by 7 plus c. Understand the difference. Next, integration of 1 upon root of x plus 5 will be log 2 times root of x plus 5 divided by coefficient of x is 1 plus c. Integration of 1 upon root of 3 minus 2x will be 2 times root of 3 minus 2x divided by minus 2 as coefficient of x plus c. Integration of 1 upon root of 5 plus x will be 2 times root of 5 plus x plus c. And finally, integration of 1 upon root of 1 minus x will be 2 times root of 1 minus x divided by minus 1 as coefficient of x plus c. As we know, the derivative of tan inverse x is 1 upon 1 plus x square. So integration of 1 upon 1 plus x square is tan inverse of x plus c. And this 1 plus x square is in form of radical, in which a is a 1. If 1 is replaced by general form of radical a is called radical, then integration of 1 upon a square plus x square with respect to x will be 1 upon a tan inverse x upon a plus c. See the difference. If a is a radical, then integration of 1 upon a square plus x square will be 1 upon a tan inverse x upon a plus c. If a is replaced by 1, then we get the standard form of 1 upon 1 plus x square dx, having integration 1 upon 1, that is 1 into tan inverse of x upon 1 is the tan inverse of x plus c. Now, using this form, we are going to form another two standard formulae of radical function. If this addition is replaced by subtraction, then the form will become a square minus x square or x square minus x square minus a square. In both cases, a is a radical, and in both cases, integration in form of log having coefficient 1 upon 2a. Then first integration of 1 upon a square minus x square is 1 upon 2 a log of mod of a plus x divided by a minus x. In log, addition of radical and variable in numerator and subtraction in denominator. In second part, integration is 1 upon 2a again log of mod of in numerator subtraction of variable and radical, in denominator addition of variable and radical. Okay, we have to move to solve example. First example is to evaluate integration of 1 upon 9 plus x square with respect to x. Solution: if I is a given integration of 1 upon 9 plus x square, as we see here, 1 is in numerator and in denominator is a quadratic polynomial having term without term of x. So this is a standard form of radical. As here 9 is a constant, we always put 9 or constant in a square. So 9 is the square of 3. So 3 square plus x square into dx. So here a is a 1. Now we compare this with any one of these three standard form. As this is the first standard form, as its integration is a 1 upon a tan inverse x upon a plus c. As a is replaced by 3, so integration will be 1 upon 3 tan inverse of x upon 3 plus c. Okay, now next example is integration of 25 1 upon 25 minus x square. So I is a given integration of 1 upon 25 minus x square. Again this is a radical form. Now we convert constant in a square. 25 is the square of 5. So comparing this with 1 upon a square minus x square, as the subtraction is a given. Always remember, if subtraction is a given in radical this form, then coefficient of integration will be in log with coefficient 1 upon 2a. As a is a 2, so we get 1 upon 2 into a, that is 2 into 5 into log of mod of. If a square minus x square is given, then always take subtraction in log, addition in numerator and subtraction in denominator. Addition of radical and variable, that is 5 plus x divided by 5 minus x, mod complete plus c. Okay, now we move to next example. Evaluate integration of 1 upon 25 plus 4x square with respect to x. Solution: let I is equal to given integration of 1 upon 25 plus 4x square. Actually here 1 is in numerator and denominator is a radical. If remember, if this is a linear, then its integration will be log of 25 plus 4x divided by 4 plus as coefficient of x, which we seen already. But this is a linear, not a linear, this is a quadratic polynomial without term of x. It is containing term of x square and constant. First we have to check coefficient of x square. Always in standard form, as 1 upon x square plus x square, or in any one of these, coefficient of x square is always 1. Here in example, coefficient of x square is a 4, so we have to make it as a 1 by taking 4 common in denominator. As 4 is a constant, we take it outside integration, but in denominator, so we take 1 upon 4 into integration of 1 upon 25 by 4 by plus x square. Check, coefficient of x square now become 1. Now constant which is in denominator will be in form of square. As 25 by 4 is the square of 5 by 2, so 5 by 2 square plus x square into d. Now compare this with any one of the standard form. As addition is there, so always its integration will be 1 upon a tan inverse x upon a. As a is a 5 by 2, so we get the final integration. As 1 by 4 is a constant, it remains as it is 1 upon a, that is 1 upon 5 by 2 into tan inverse of variable x divided by radical 5 by 2 plus c, which is a final. Simplify this or remain it as it is. Next we move to next example. Evaluate integration of 1 upon 25 minus 9x square. Okay, solution: I is a given integration of 1 upon 25 minus 9x square. C, 1 is there and quadratic polynomial in denominator. This is a radical form with coefficient of x square not equal to 1, so we have to make it as a 1. But here is it is given is minus 9. As we can make it as a plus 9 or minus x square will be alright. So we take only 9 common out of this denominator. So out of integration we get 1 upon 9, in integration 1 upon 25 divided by 9 minus x square. Now make the constant in term of square. 25 9 is the square of 5 by 3. So 5 by 3 square minus x square into dx. And finally compare this with any one of the standard form. As there is a subtraction, always integration is in term of log with coefficient of 1 upon 2a. So 1 upon 9 remain as it is into 1 upon 2 into a is 5 by 3 into log of mod of. Now a square minus x square is given, then in numerator addition of variable and radical, that is 5 by 3 plus variable x, and in denominator subtraction 5 by 3 minus x, and plus c is our answer. Okay, next we move to another example. 1 upon 3x square plus 4 into dx, plus 4 or minus 4 with respect to dx. Solution: I is given integration of 1 upon 3x square minus 4 with respect to x. Again, this is a radical form having coefficient of x other than 1. So we make it 1 by taking 3 common in denominator. In out of integration we get 1 by 3. In integration 1 upon x square minus 4 upon 3 into dx. Now make this constant in term of square. 1 upon x square. Actually 4 upon 3 is the square of 2 by root 3. Now compare with this one of this form. As there is a subtraction, this integration is in term of log with coefficient 1 upon 2a. So 1 upon 3 remain as it is. 1 upon 2 into radical is 1 upon 2 upon root 3. So 2 into 2 upon root 3 into log of. Actually here is x square minus x a square. In this form, in term of log, subtraction of variable and radical. So variable x minus radical is the 2 upon root 3, and in denominator addition x plus 2 by root 3. Mod complete plus c is our answer. As derivative of sine inverse x is 1 upon root of 1 minus x square. Therefore integration of 1 upon root of 1 minus x square is equal to sine inverse of x. As this 1 is replaced by radical a, then form will become 1 upon root of a square minus x square, and its integration is sine inverse x upon radical a plus c. If this a square minus x square is replaced by x square minus s square in a root, then its integration will be log of mod of x plus root of x square minus a square plus c. Or this is these last two form are root of x square minus a square or x square plus a square. In both integration is a log of mod of variable x plus denominator, if it is root of x square minus a square or it is a root of x square plus a square. So remember these formulas. Now we solve the example. The first example is evaluate integration of 1 upon root of 25 minus x square. Now in solution I put I. In numerator there is a 1, so this is the radical form, as denominator contain a quadratic polynomial in root. Remember, with root, without root, both are different. If there is a without root, then its integration will be, as radical is 5, 1 upon 2 into 5 log of mod of radical 5 plus variable x divided by radical 5 minus x plus c. But in this example the denominator is in root, so we have to use out of this formula. Now 25 is a constant which is the square of 5, so 5 square minus x square. Now this is a subtraction of radical and variable. So this integration will be 1 upon root of a square by x by using formula 1 upon root of x minus x to sine inverse x upon it. The simple integration is a sine inverse of x upon radical is a 5 plus. Okay. Now next example. Evaluate integration of 1 upon root of 9 minus x square. So I put this integration as a I, root of 9 minus x square. Now we make first 9 as a square of 3. Now this is again in form of root of a square minus x square, so its integration will be in sine inverse of x upon radical is a 3. Now next example, evaluate integration of 1 upon root of x square plus 9. I put this as I is the integration of root of x square plus 9 into dx. Now make this constant in a square. Again 9 is the square of 3, but in the root we have a addition. By using this last formula, as integration of this is a log of mod of variable x plus denominator, that is root of x square plus 3 square mod complete plus c. Now again this is I is equal to integration of 1 upon root of x square minus 3. Now this 3 is the square of root 3. So in root of x square minus root 3 square. Now compare this as there is a subtraction which is in form of x square minus a square. So again this integration is in log of mod of variable x plus denominator as it is x square minus root 3 bracket square mod complete plus